In exercises 37 through 52, we want to find all relative extrema, and we want to use the second derivative test where applicable. So let's just review. We have talked about the first derivative test, and the first derivative test is as follows. The first derivative test says that when the first derivative changes from positive to negative, f of x has a relative maximum at that point. And that makes sense because if we have a curve and our derivatives go from positive to negative, we have to reach a peak at some point. The function went from increasing to decreasing. So with the first derivative test, we're just looking for the change in the first derivative from positive to negative. That indicates we have a relative maximum. Similarly, when f prime of x changes from negative to positive, f of x has a relative minimum at that point. And again, it is very logical when our slopes go from negative to positive, and obviously we have a continuous and differentiable function, then we're going to have a relative minimum at that point. That's what the whole first derivative test is all about. Now we're going to do something slightly different than that, or another way of finding relative min and max, and that's called the second derivative test. And the second derivative test says this. Well, if I have a function that has a zero derivative at some point, that means that I have a horizontal tangent at that point. And furthermore, if that function is concave up at that point, then I must have a relative minimum. So concave up means that the second derivative is positive. So when f prime of x equals 0 and the second derivative is positive, greater than 0, then f of x has a relative min, at that point. So similarly, if I have a curve that has a horizontal tangent at some point, that means the first derivative is 0 there, but the second derivative is negative at that point, then I must have a relative max. So when f prime of x is 0 and f prime prime of x is less than 0, then f of x has a relative maximum at that point. Now, the first derivative test always works. When I get a change in sign of the first derivative, I either have a relative min or relative max. The second derivative has a third option, and that is when f prime of x is 0 and f prime prime of x is 0. The second derivative test is inconclusive. So, and that'll happen, for example, well, when the second derivative is 0 and the first derivative is 0, then the test is inconclusive. And we'll suffice it to say that that could happen from time to time. So let's jump right into this with number 37 then. Number 37, we have f of x is equal to x minus 5 to the second power. We know this is a parabola. I can tell by looking at it that it has its vertex at x equals 5, y equals 0, and it's going to be a relative minimum there. But let's assume we didn't know that. We find the first derivative, we bring down the 2, multiply by, leave the inside alone, x minus 5, reduce the exponent by 1, and multiply times the derivative of the inside. And we get 2 times x minus 5. Now we know that that is equal to 0 when x is equal to 5. So we know at x equals 5 we have a horizontal tangent. So let's go on to the second derivative then. And the second derivative will be, if I multiply that out, 2x minus 10, the second derivative is 2, always, which is greater than 0, so it's positive. Therefore, since f prime of 5 is 0, that means we have a horizontal tangent when x is 5, and f prime prime of 5, the second derivative is positive at x equals 5. F of 5 is a relative minimum. And that's like that example there. We have a horizontal tangent at x equals 5, and the function is concave up at that point. Therefore, we must have a relative minimum. Let's look at number 39 then. 39, we have f of x is equal to 6x minus x squared. F prime of x is 6 minus 2x, and that will equal 0 when x is equal to 3. So let's see what happens. F prime prime of x is negative 2, which is less than 0 for all x. Therefore, since f prime, I should say, of 3 is 0, we know we have a horizontal tangent, and f prime prime of 3 is negative, we must be concave down, then f of 3 is a relative maximum, and that is similar to the second case there. So hopefully this makes the second derivative test a little clearer. We'll see further examples of this.